Okay, so welcome to lecture, I said lecture 5. I believe this is lecture 7, so I've got to correct that right away. This is lecture 7, which is on Lean Part 1. And here's what we're going to cover today. I'd like to, first of all, take a little bit of time. That's how I know it's lecture 7, because we'll review lecture 6. But I'd like to take a little bit of time to quickly review and brief lecture 6. Just to mention to everybody, again, the last assignment is pretty lengthy, so if you haven't yet started, you're risking being able to turn it in on the 7th, which is when it's due. If you haven't yet turned in the previous assignments, that puts you at double disadvantage. So please get to that as soon as you can. I also want to mention that the very last part involves talking with a specific other person in the course, not of your choosing, as it has been in the past. So if you haven't yet made the appointment to talk, I would urge you to do so right away. There's a number of people in here who are very, very busy. I think that probably includes all of us. So let's make sure that that happens. I know one pair has already made a plan to talk, and it's me and Tracy. So I don't know about everybody else. But if you haven't yet gotten something on your schedules, do so. The talk should take half hour minimally. Okay, so you don't want to take more than, say, 45 minutes, but certainly not less than a half hour. Okay, so that's what you're doing, and that was in the last assignment, which was assignment number 3. Additionally, if you're a black belt, you've got a lot of things to work through in those examples, so make sure that you do so. Let's see who's just joined us. I believe it's Shani and Sue, so they'll be on in just a moment, which is great. Okay. All right, so here's the agenda for today. We'll quickly review lecture 6. I want to take you through, since most of us already know a lot about Lean and have applied Lean in major ways, I want to go through that fairly quickly in terms of what is Lean and what are some of the Lean metrics. I really just want to direct you to some of the Lean metrics and what there will be an assignment. There's an exercise I want you to do for assignment 4, which I haven't yet assigned, but that involves looking at a process and saying which metrics might make the most sense, getting some data. So I want you to go through that. But we'll spend most of our time looking at Lean tools, some nuts and bolts Lean tools, and then spending some time talking through Lean solutions. Now, I do want to spend the very end of the lecture talking through a little bit on hypothesis testing and confidence intervals, just for means, okay? And what I want to do is I want to run through a few examples, and that'll give you enough to do the first half of one of the sections that's in week 4 on hypothesis testing. It's really a key concept in statistics, and as a black belt, you need to have it. As a green belt, it's also very, very helpful, I think. So I want to give you a few examples there. We'll spend a little bit of time wrapping up. If you have any questions, I'll stay on the line afterward. But that's what we're going to cover today. So first of all, I want to field any questions that you might have. So if there are any questions, please ask away. Don't have any response right now, so let's just go ahead and I'll very briefly take you through a very brief, let's see, why is this not working? Very brief debrief of the last lectures. Okay, so again, I want to emphasize that we've been talking about something that I call the data analysis algorithm, and and we talked about the advantages of using something like this. It's definitely going to give you easier use or easier and clear choice of tools. Okay, so when you want to know which tools should I use, this is going to help you that. It's going to help ensure relevant completeness of analysis. It's an analysis algorithm. Completeness. It's going to help ensure relevance. A lot of people analyze data that's not relevant to problems that are in the business. We don't want to do that. And it's going to help ensure timeliness. Okay, we don't want to fall into the dreaded analysis paralysis. We all know that we've done that in the past, or most of us have done that. And it's largely what gives Six Sigma, and particularly black belts, a bad name. And yet, if we want to get if we want to really make some breakthrough stuff, if we want to see that 1%, we're going to have to use measurement and statistical tools to do it. Yeah, to get the big stuff, process map, certainly just fine. Pareto analysis, certainly just fine. But to get the little stuff, we're going to have to really do some analysis. Now, the algorithm works like this, and I'm just going to do this very quickly, not even an example. We've done the example of the restaurant many times. But essentially, you start out with identifying your key output. It may have more than one, but let's just keep it as one. And then all the potential drivers of that output. Okay, and we'll call these X's and Y's. Okay, and I'm envisioning that the analysis takes place after you've already collected some data on all these X's and Y's. And what we've got is essentially we've got columnar data. Maybe it's as an Excel spreadsheet. I'm giving the first row here. Maybe this is Y, this is X1, this is X2, and so forth. Okay? And what we're going to tactically go through is for each pair, first of all, we're going to label them as N or C. N for numerical, C for cat. Let's make that a number. Okay. But that is the most common, is num cat. One num, one cat. That's by far the most common. Okay? And then tactically going through for each pair and considering the following. Drawing the PGA wheel. Okay? Starting from practical and working yourself all the way around back to the start, ending with the practical again. And it starts like this. You ask the question, I wonder if X1 is a driver of Y, okay? And noting that, oh, I have this type of analysis to do. Moving on, making a graph. That's the first thing that you do. All right, and I've been emphasizing that the first thing that we want to do is look at plots, not look at numbers and calculations. Okay? Second thing we want to do is if we see something in the plot, generally we will, if we see something in the plot, back it up with some analysis. And this just says, is what I see in the plot, is what I see, or what I see in a table of numbers, if you really must insist that looking at a table of numbers instead of a plot, is what I'm looking at in a table of numbers statistically significant? If it is, you essentially circle. If it isn't, you essentially cross it off and move on. And the move on means if I found that, for example, here, X1 is a driver, I'll rewrite it because I covered it up. X1 is a driver of Y. Then I've got to think about what I can do with it. Do I have an immediate solution that I can craft? Do I need to collect more data? Do I need to drill down into why X1 is a driver? At least now I know that my drilling down will not be in vain and it won't be a wild goose chase. I'm doing it for a real purpose. So that's the idea, and effectively what you're doing is you're building up this process or this picture of which factors, which of these drivers really does make a difference on the key output that we're looking at. Okay? All right, so I keep saying this over and over because it's such a key concept to get into ingrain. All right, the other thing that we covered in the Friday lecture which was also the same as the Thursday lecture, was something called capability, right? And capability is the VOC part of my baselining. Remember, I've got the VOP and the VOC, and here's my customer, and here's my process, right? That's my process. Okay, and the VOP I look at by looking at a control chart. The VOC I look at by doing capability analysis. And effectively what I'm really trying to do, let me connect the dots here. Okay, and I'll put in my red lines because this is a control chart. This, by the way, if I had a control chart that looked like this, whoa, it would indicate that I have a stable process. Here's my KOV, and this is time. Okay. On the other hand, I might also look at my capability, which capability is, it's kind of like a histogram with a line in it, right? And I look at the percent bad. Okay, so no matter how I slice it, capability is percent bad, or again, if you're a half glass full person, it's percent good. So again, it doesn't really matter if we say the process is 97% good or 3% bad in theory, but in practice it really might. And that's for you to kind of work out and decide in your own situation. Sometimes it's hard to motivate people past the 99 percentile, or the 99%. For that, you might consider using sigma level, which is also percent bad in its Halloween costume. Anyway, the capability is essentially percent bad / percent good. Okay, and we also looked at how to do it. And we had a few different methodologies. We said that there was a lot that was out there, but essentially there are two situations. First of all, is we have a lot of data, we simply can count, and our count is meaningful. Okay? It looks like coconut or something. That is count. I have to write better. C-O-U-N-T. Okay, there we go. Count. If we don't have a lot of data, if we have little data, we essentially use the tools in Excel Stats, which was PDF, or in Minitab, which I believe the tool of choice, in my opinion, is to use a probability plot. A probability plot you can use for lots of different things. We'll examine one other in the next lecture, not in this lecture. But basically, here we're looking for the area under the curve. Okay, for capability, we're looking for the area under the curve. So essentially what we do is we take whatever our histogram is. See if I can draw a decent one. Take whatever our histogram is, and we essentially fit a nice curve to it. If we have a lot of data, it's going to be fine, and we can just count. And then we calculate essentially the area under the curve past the spec. And that will tell us the percent bad. Okay? All right. So essentially that's what we did. If you're not getting that, feel free to call me and we can talk it in our one-on-one sessions and work it all out. Okay. So I think at this point we'll go into talking through lean. And again, I just wanted to, for the folks of you who joined a little bit late, I want to emphasize that for this third assignment, the last part involves you making scheduling a talk with another person in the class, and that person is assigned. So you don't have a choice of who you do it this time. Or who you talk to. So please please arrange that assignment now. Don't wait until after you finish, because to do it at the last day, you and I know it's not going to happen, or it's unlikely to happen. So see if you can arrange it now. Okay. I think I've admonished enough on that one. Okay. Let's talk through. Let's start out by talking and moving into our lean introduction. So I'm going to do that. This is beginning on slide 2. So we're talking about week 4. It should be week 4 in our book here. All right. So now this is entitled Lean for Black Belts. It's really kind of in 2 parts. There's an introduction, and we'll talk about things later in the course. We'll be talking about some things that you would learn in like an operations management course in an MBA program. Things like optimization, linear programming, and queuing theory. And even if you don't learn the theory, there's some nice things to know that the tools exist and that you can actually examine these things. And it's actually not that complicated to learn what are the basic questions that you want to ask, and I think that's valuable for green belts too. But it is what I would say advanced, certainly advanced, what people are calling advanced lean. So we'll take a little bit of time to go through the introduction, and here's kind of what we'll cover throughout the. I do want to open this back up. I'm sorry. Throughout the course in Lean. So we'll talk about today. We'll talk about some of the goals and principles. We'll talk about some of the metrics, and then we'll spend some time, a good amount of time, talking about the nuts and bolts tools and the typical Lean solutions. That's what we're going to talk about today. We won't be talking about the goal. We won't be talking theory of constraints. We won't be talking about constraint optimization, queuing analysis, or process simulation. Okay. So without further ado, let's move on into some of this. So I'd like you to. So first of all, we want to make a bit of a distinction between Lean and Six Sigma. And I don't think you need to always make this distinction, because typically the two tools and the two paradigms and the two methodologies can be meshed together pretty well. But they do have different origins. And for example, Six Sigma largely came from the quality movement. And so as such, it was looked at the techniques for, a lot of Six Sigma is about the techniques for reducing defects and reducing variation. Whereas Lean, most people talk about the Toyota production system. Lean came about through slightly different ideas and methodologies. But at its heart, Lean is really about reducing waste. Some other thing it's about are essentially, well, we'll talk about what are some of the wastes that we see, and one could say that some of these other things I put in here are about eliminating waste also. But there's a couple of key aspects of Lean that I wanted to point out. And that is that it's about teamwork, but in a cultural sense. So to really make the Toyota production system work, there has to be an effective culture change. It can't just be improvement teams, okay? And when I say it's about teamwork, what I mean is that it's about understanding your organization horizontally and not just vertically. Third thing is it's about speed. So most Lean practitioners, their first metrics of choice are around cycle time and reducing cycle time. In fact, I read a book, I'm trying to remember what book that was, Lean for the Small Shop or something like this, years ago. It was a Shingo Prize winner. Shigeo Shingo is a Lean guru. And it was basically, it was subtitled, "It's About Time," and with a double meaning of that phrase. But the argument for why it's about why speed is important is really about getting products to market faster, servicing customers more quickly, and also generating better cash flow So most lean practitioners talk about all three of those things. Now, most of basic lean you already get, and but what I can tell you is that sometimes in a lot of practices, people aren't focused on eliminating waste. They're focused on making their core processes even better or higher quality, whatever that means. It doesn't always mean the same thing. So lean helps you put your hat on and say, okay, if that's well and good that we want a high quality process, but maybe there are lots of things in here that we're actually not, or that we're actually doing that we shouldn't be doing. And if we stop doing them, we'd be better off. So there's lots of different things. There's lots of different things. You already get lean. Most people, and I think that the folks who are in at Baptist, you've already done a tremendous amount of work in lean. So so I think that there's a good understanding there. Okay, so let's talk through a little bit about maybe the distinction between when lean might be predominant and when Six Sigma might be predominant. One way of thinking about that is that Six Sigma tends to work on particular processes. So, for example, or particular steps of a process. So if this particular step was problematic and produced a lot of errors or a lot of variation, the tools for Six Sigma, data collection, deep data analysis, decisions on when to hire a contractor or not, Six Sigma may predominate. On the other hand, if the overall flow is an issue, which might be the time that it takes to make this whole thing happen, or maybe the way that units move through. Do they move through? Do they get clogged at various places? Are there bottlenecks? Lean tools and solutions can be, and lean thinking can be often helpful. Okay, and that's just what this says as well. All right, here are some of the key principles of lean on slide 8, and you'll see, I think, that most of these are not are in line with Six Sigma as well. So determine customer value, that certainly dovetails with Six Sigma. Making the value flow, we'll want to talk a little bit about that. We will want to talk a little bit about that, but that is one thing that is a little bit different with respect to Six Sigma and lean. Flow is a much more prevalent concept in lean, and I like to think about it this way. What flow really means, and I have here, is the customer pulls the value. There's lots of different things to think about for this, but one way of thinking about it would be to say that every time the customer wants your good or service, they're able to get it as soon as possible, and that all the processes or tasks that have to happen to make that delivery of that product or service possible go into action immediately without delay. So, for example, and we'll talk about this in an example later, when you go into Subway, and people are probably sick of this example, but when you go into Subway, they don't have all these sandwiches pre-made, but when you order something, they pull an order just for you, right? And they have to pull it immediately, otherwise it's not going to be valuable to you. All right, that's probably the simplest way to think about it. And the way that I learned it, the way that I learned this is to say, think about, I learned this in a manufacturing setting, so I learned it for product, but now lean is, of course, applied all over the place in service and product. But I learned it to say that products are impatient. So if you anthropomorphize your products, certainly people, it's easy enough. If you anthropomorphize your products, you start to think, well, they're impatient. They don't like to wait. And so it helps you see, when your paperwork or your transactions, your billing, anything like that is being held up. Okay, so that's the one thing that is definitely different. Understanding the value stream, we'll talk more about that later, but essentially at the moment now we can think of that as the horizontal as opposed to vertical process that things have to go through. Getting it right the first time, that certainly is very similar to a Six Sigma paradigm. Make our processes transparent. This isn't something that all lean folks talk about, but I like to specifically point it out because most lean tools will find, if you don't already know, are visually oriented. They're simply made to visually display waste and how much it's really killing you and killing your operations. So until you can see it, and in fact, I'm trying to think if it was, I don't think it was Womack and Jones who are essentially the two lean gurus, but the person who came out with Learning to See. By the way, I'd appreciate if anybody knows the author of Learning to See. If you could let everybody know who that is. But Learning to See is largely that was the whole point, is that you can't see, if you can't see the waste, you can't do anything about it. So the lean tools and the metrics are about illuminating that. There's also an extra emphasis, I believe, in many lean programs on doing it right now. If you don't need to wait, why not? Why keep waiting? Why not do it right now? And finally, compete against yourself. This is also true in Six Sigma and in the quality world, but it is very explicitly pointed out in most lean organizations that the competition that you've got is yourself. So you're never really finished when you go through the steps to make a process lean. Guess what? You still have work to do. So those are some key principles that we can go on. Okay, so just as a very quick, sort of tactical view of this, many companies, and I think this is part of the whole culture change that we as black belts have to work to, whether it's Lean or Six Sigma, but that most companies see themselves as organized around departments, right? So if you're working with somebody who is, say, the COO, they're going to think mostly in terms of operations. If you're looking at product development, they're going to think mostly in terms of product development. Marketing thinks in terms of their own interests. And in fact, most metrics are also geared that way. So when we have many I've certainly reviewed many Greenbelt projects, and most Greenbelt projects tend to look like this. Here's their SIPOC, and their metrics are end to end from here. I'll just put E to E here. Their KOVs are siloed metrics. But the big problems, of course, are generally ones that go across value streams. This, by the way, is what I'm talking about, a value stream, something that goes across many departments. If you think about it, the services that you give to your customer, if I have a customer over here, and maybe that same customer or a different customer over here, whether it's care delivery at a hospital, whether it's the administration or the completion of a sale with an employer, or whether it's finishing up a brake pad and delivering it to the distributor, that those things cross many departments and involve much more than simply the core operations. They involve all of these things. So first thing is to start thinking of your value, what we call our value streams, as they go horizontally, not vertically. So that means our metrics really should, for these particular value streams, should be metrics that encompass the end-to-end here. Our KOVs should be things that, for example, don't measure cycle time to complete this, right, but measure cycle time across this value stream. All right, I'm probably preaching to the choir at this point, so I'm going to move fairly quickly. The really relevant question is, so where do we start and how do we define these value streams? Because I think once we create them, it'll make some sense. So I want to talk through a tool maybe that can help you to do that, okay, and sort of how to use that tool. But by the way, many companies advise that If you look at a company or a corporation, they can have multiple levels. Like, for example, and they can have more levels than this, too, but I've just written this. So maybe this is one of the things that can be looked at would be Baptist Health System. There's multiple businesses, right? There's multiple hospitals. I'll just say H1, H2, H3. And then there's multiple processes within each one of these hospitals. For many folks, people might say, you know, a good place to start would be here and say, what are the key value streams that each of these business units have to deliver on? In this case, there's a lot of commonality, but there may be some differences if you have outpatient clinics, things like that, convenient care clinics. They may have different value streams than the hospitals. If this were Connecticut, see if I can erase this just a moment. If this were Connecticut, we might be talking about, here is, I believe, Emblem, and then CCI is the business here, and the cross. So that's kind of where we would start to define our value streams, and we look for the multiple the things that are that we do, the functional value streams at Connecticut. That seems like a reasonable place to start. So starting a value streaming initiative or a value stream initiative at Connecticut is right and proper. You don't have to go up or go down. All right. So how do we actually get to get to defining tactically what these value streams are and then looking at them cross-functionally? Well, one way of doing it is to list many of your processes, and I learned this as what was called PQR, product quality routing. And essentially what we would do is we would say, what are the different stations or build stations or measuring stations that we need to do I happen to learn it in amplifier business. So what are the different build stations that we need to look at when we're making the different product lines? So I thought of these as different products, right? So I had a product A, product B, product C. You could look at them as services as well. And then I simply went through and I said, okay, for this particular service, do we need to go through estimate and quote it? Yes, no. If we do, put an X, otherwise put a no. And you'll start to see that there's a lot of commonality. So for example, this might say that these particular services would have their own value stream. Here's one value stream that we would want to look at. And these particular services, A and E and F, have another particular value stream. Here's another one, a value stream that we'd want to look at. Okay, so again, so tactically, what this would mean was, and I'd be guessing at Baptist, but this would mean, you know, you're going to have value streams very, very high level, like revenue cycle, care delivery, and so forth. But there's probably going to be value streams within, say, care delivery that you'd want to do. But there's also going to be some commonality. So, for example, you'll certainly have a process map and a value stream map for bowel surgery, but that may not be the main thing that defines the initiative. There may be other surgeries or other type of care, other type of procedures that could be looked at as having very, very similar value streams, and that can really help congeal the sort of model that you want to say, I have X number of value streams. And those value streams can have very, very similar metrics like cycle time or WIP, work in progress, or on-time delivery, all those sorts of things. Hopefully this is making some sense. By the way, I appreciate anybody I know Baptist, you have a very active program in Lean and doing value stream maps, and you're building that up. So it would be very helpful if you could, if anybody could share that. Maybe what are some of the value streams that you look at? Okay. What I can tell you is I worked at a company that had many medical practices, and they had 4 basic value streams that they went to each facility with. They had 4 value streams, so they had thousands of facilities. They went to each facility or each provider facility and medical practice, and they had 4 value streams. One was care delivery. One was revenue cycle. One was drug management, and one was referral cycle. Their revenue was very dependent on getting referrals and managing those referrals well. So they could go into any practice and have a common number of metrics, even if one was a pediatric care facility and the other maybe was an oncology facility or a radiology facility. But this gave them some very clear structure, and that's what the value stream did. Okay. Okay, so hopefully we'll move on, and I'll take any questions you have. But I do just want to say that in the next assignment, not the one that you've got right now, but in your next assignment, you'll be asked to do a little bit of writing down what your value streams are, and outline why is this the value stream you're looking at, as opposed to other things. Okay. All right. So I'll stop here, and we've finished through this particular section. And I want to stop and ask you for any questions that you might have. If you have any questions, please feel free to ask. Okay. All right. I do want to talk just a little bit about the lean metrics in here, and I don't think there's anything in here. I'm going to ask you to read this section over, but I do want to take some time to talk to you about a couple of these different metrics, and then tell you about an exercise at the back end that I think will help you a lot in working this through. The things that may be different to you as you go through here is this. First of all, this concept of takt time. So I'll take a little bit of time to do that. There's also under lead time, cycle time. I just want to mention these things are often talked about as exchangeable. We have specific definitions in this particular text, but a lot of time people can refer to lead time as cycle time, or turnaround time, or process lead time, or process cycle time, or elapsed time, or touch time. That's another one I forgot to put in here, touch time. That's another one that sometimes they confuse those things. We're actually not talking about touch time. We're talking about an end-to-end elapsed time between one thing happening and another thing happening, usually order to delivery. That's usually what we're talking about. Okay, and I just want to also point out there may be a foreign concept here in something called ruled throughput yield, but I don't think it's going to challenge anybody to work these through. I think you'll get them all. So as you read through these, feel free to give me a call, and we'll talk through them. But I don't think any of this should prove any difficulty for you. Okay. Okay, so this will be certainly on your reading, and all that's well and good. there is an exercise at the end here, and you're actually given a challenge with a data file. You're given a sales process, and you can see that, if you're in a board meeting, this is not what you want to see. Sales is going down, and your assignment is going to be, or your mission, should you choose to accept it, is to examine the data and to determine what metrics might make sense, and to put together a plan based on the basic process of the sales process to say what we could do to get it back on track. So hopefully that'll give you a good idea of how you might look at this with respect to lean metrics and some of the metrics that are used in there. Okay? All right. So this is another one of those that is going to be, I will post a separate video of this, so you'll be able to view it, and then of course you can ask me any questions in our one-on-ones. But you'll have this. Okay. Now I want to spend a little bit more time talking about what I call nuts and bolts lean tools. These are just the basic tools. Now, one of the things that when people study what has happened in lean in America as opposed to other places is there's an overemphasis on tools. Did you use this tool? Did you use that tool here in America? All right, having said that, there are some tools that are so multi-purpose that they really repay over and over. So I want to go through what those tools are, at least in my book. Some of the most valuable ones are value stream mapping, and we'll talk about this. We already talked about value stream mapping from a high level, but there's a high and low level. High and detailed, I should say, detailed level. Okay, there's both of those. I'll leave this on. Where was I? Sorry about that. There we go. Okay, so the value stream map has both of those. We'll also take you through something called process analysis and waste walk. I think that these will be very obvious when you look at them. The question is sort of when you want to use them. Value stream map can be used multiple times. It can be used at a high level, like I said, high level, and also at a detailed level. So the high-level analysis can be done early in a project, or it can be done even prior to a project to help select that project. That's the ideal situation. Process analysis, the way that we present it, is only going to be done at the detailed level. So it's appropriate when you've already really examined and found a problem with a specific point in the process. What we call 5S, that again is a detailed level practice, and the same with waste walk. The waste walk can be done early, but is also a detailed level. Generally speaking, is a detail level tool. Okay, so these tools can get you from fairly high level to fairly detailed stuff. So let's cover them through. As I said, lean tools are really about seeing and eliminating waste. Let's talk first about value stream map. And again, value stream mapping, there are many, many books, and there are many, many ways in which people are proponents of value stream maps. The way that I like to think of a value stream map is think of it kind of like, we all know what a regular process map or flow chart is. Think about it as a flow chart on steroids. And if you start about thinking as it that way, you'll start to realize that maybe it's just additional components that are put into a process map. So let's talk through, here's a methodology on how to do that. Instead of doing that, let's talk it through in a picture of what a value stream map is, because it can be very daunting if you haven't seen one before. So here happens to be a picture of a value stream map, and let's talk it through in terms of everything that's here. So one thing you'll notice is that there are many, many symbols. I would again encourage you that when you do your value stream maps, not to use so many symbols, because symbols can often get in the way of communication, and therefore get in the way of other people visualizing and understanding what the problems are. So so I would say use them sparingly. But we'll talk through what's here. Believe it or not, this really is at its heart simply a process map, and a rather simple one at that. This happens to be a value stream map for underwriting at a financial services company, and for approving policies at a life insurance company. And think about that. Okay, so first of all, I want you to note that, and we'll just kind of go from the bottom up, that maybe I should have said this first, but the process steps are given, basically the internal process steps are given right here. I'm just going to mark them in red. I should use my pen. How about that? If I use my pen, do a better job. There we go. Okay, so this is maybe step 1, and step 2, and step 3, and step 4, and step 5. These would be the internal steps, and maybe even step 6 if we're talking about shipping as well. So if we looked at it internally, the process would be I enter data, I get my requirements, I do my risk assessment, I do my inspection of the policy, I do my inspection, I do a policy assembly, and then I ship it. Okay, so that's the process itself. At the bottom, just to show you what's here, we often put in timing data. And you can see that the top is usually, there's usually non-value added and value added. This is actually the task time for each of the different process steps, you can see. And then on the higher level is the delay. So this one takes 45 minutes to do, and then there's a 20-day delay after it, after which there's a 10-minute process, after which there's a 3.5-day delay, a 2-hour process, and so on, right? So something like this, if you've identified, can really show you, oh my goodness, there's a 20-day wait. Maybe that's really hurting the customer. Okay, second thing is there's also some process data that's usually put on here. Okay, and that process data is, it varies by the type of process that you have, but basically it uses many of the lean metrics that we talked about before. Here, in this particular process, it gives us the cycle time, that's what CT is, the batches that are used, in this case maybe a batch of 50. Apparently the uptime of this particular thing is important, because that can certainly cause delays. And that's given at 90%. So that could be even IT uptime. And this bottom thing, which is called IGO, stands for in good order. That's a percent good. So that's percent good that's coming through here. So we can see, for example, if we want to look at processes that take a long time, this particular process takes the longest time at 120 minutes. They all have batch sizes of 50. They all have 90% or greater uptime, but one of these has a very low in good order. Actually, two of them do. That one's got a problem with in good order, and that one's got a problem with in good order. So that's like quality level. Okay, so that can help us understand maybe what's wrong with this process and give us an idea of where to work on, and where and what to work on. The third thing that's on here that may look a little non-standard to you is inventory levels. So these little triangles right here are given for data that's in progress, or stuff that's going between, that's done with 3 and waiting to start at 4. We'll find that one of the wastes that we look for in lean is inventories. So this can help us understand where inventories are great. So look at this right here. It looks like right here we're batching up. We're allowing ourselves to get up to 2,000 policies. And maybe that's what's really causing the problem with the delays. So it's helping build that picture in a meaningful way. Oops. Now, many of these other things are sort of optional I think, as I've seen. I don't always see them in value stream maps. In fact, I don't always see inventory, although I think it's usually a good idea to indicate work in progress. But scheduling and things like that, where the scheduling is coming from, is often noted. Some people want to use some people use it's been a while, but some people, instead of putting just a straight arrow, would put an electrical looking arrow for electronic transfer as opposed to just regular transfer. Oops. And so forth. Okay, and then usually up at the top. So if we kind of strip this a little bit and strip out some of the stuff that's kind of getting in the way. Oops. We've got just a few different elements that we care about. First of all, here are the suppliers and customers. Here is the process itself. And then these arrows are kind of showing where things are pushed. See, that arrow is pushing this way into various places. Okay? So, and then there's just additional data that's put on here. Timing data, process data, queue data, and scheduling information. Okay, so what can you do with a value stream map? Well, if you have, and here's, by the way, here's our lightning bolts. You see those lightning bolts right there? That's what I was talking about before. So if you have, remember we said one of the key things was to let the customer pull. One of the things that a value stream map can do is it can really help you understand where various wastes are happening and help you understand how to build a pull system better. So this happens to be for a different company. You can see that here they're doing milling, welding, and painting and assembly. But it allows you to start with getting a big picture of where your delays might be, where your inventories might be, and where you might be able to design pull systems as opposed to push systems. Okay, so you might be able to design a before and after, and or a current state, and then what the future state might look like. You can see that this is cleaned up quite a bit more. You've got all this scheduling that's going on in the middle of the process. Here you've moved it to the ends, which is more efficient. And instead of these arrows, which are push arrows, you've got pull arrows, which essentially that usually helps you a lot with inventories. So that essentially says whenever we're out of materials from milling, that's when we're going to pull from the supplier. Or there may be rules around that. We'll discuss inventory management much later in the course, and reorder points and all that kind of good stuff. But you can see that that can reduce a lot of waste. Think about it in terms of if you're in the medical practice or medical or healthcare provider side. Think about maybe how wasteful it would be to push a patient through into a room which is not cleaned, or to push a doctor to there as well, to a room which is not prepped and patient's not ready. It's a tremendous waste. So here, if you design something where only when the room is needed is it pulled into availability, that might be the design. These little lightning or these little flash symbols right here are indications that there may be a project opportunity. They're called Kaizen bursts. Again, you can look that through. Here are just a few of the VSM symbols. The Bart Simpson's hair right here, that's for a customer or supplier. I believe that's just supposed to be looking like a factory, but you can see it right there. Process steps are usually noted by that. There's my pull arrow. There's my electronic info flow. There's my push. my Kaizen burst, my inventory or queue, and then the data box, which you saw right here. Okay, and like I said, use these pretty sparingly. What I would say is that if you're going to use these sparingly, make sure that yes, process steps are used. I like these. I like putting inventory triangles in, and data boxes. I find are very helpful. Do I need to use a separate symbol for the customer supplier? Sometimes it's helpful, but again, you have to be willing to talk it through. And the push and pull arrows, again, they're helpful, but only if the person is in the conversation. So you may want to prepare a simpler map for a presentation, just so that people can see it and not get freaked out. Okay, I'm going to move on from value stream maps. That was just a very, 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 very high-level introduction to them. It seems that so many people and organizations have different ways of doing them. So just use this as a guideline, and I think you'll be in good shape. Okay, I want to talk a little bit about another thing that I call a waste walk. And a waste walk, I literally think of this. I literally think of my engineering days when I would take out my clipboard. I would go out to the factory floor or the plant floor, which obviously could be the floor of a hospital, or it could be the floor of where the people are doing their sales, or where they're at Connecticut, I'm thinking, or in the call center. And what I'm doing is I'm noting. I have categories for all these different things, and I'm noting where wastes are occurring. And I just use this model as something that helps me think of something. It just helps me think more specifically about waste than I have in the past. So in their book, The Machine That Changed the World, Womack and Jones, who are two lean gurus, they were the ones who originally went over, at least got the press on it, went over to Japan and studied over there and came back and said, this is what Toyota Production System really is about, and here are the things that they're doing. They identified 7 wastes. We'll talk about the 8th waste. I know that many people talk about the 8th waste today. I'm always wary of that one, of introducing it, but we'll maybe like to get some of your opinions on that. But let's start through and talk through. Here are the 7 wastes, and I remember them by remembering the acronym Tim Wood. The wastes are transportation, moving goods around a lot. You can imagine, say, or it can be moving the patient around a lot, or papers around. But you can imagine if you're building, like if you're United Technologies and you're building jet engines, if you have to move that jet engine more than you need to, that's a tremendous amount of energy and cost and waste. Inventory. There's a tremendous amount of waste in inventories. If we're holding goods that we will never sell, that's a problem in finished inventory. If we're holding sub-assemblies, they can spoil, they can get stolen. So there's a lot of problems there. I think we all know what inventory is, and so we can talk through maybe an example. Motion. So here I'm talking about usually that's separate from transportation. So that might be people moving too much. I might have a poor work area designed, something like that. Waiting, those are also called delays. Okay. And then we've got a couple here that are interesting. Overproduction, which is literally making more than we need to make, making more than we can possibly sell. That's a tremendous waste. And overprocessing. So this is doing more than what we really need to do to satisfy customer needs. So this is overly complex processes and so forth. And then finally, defects. These are errors that somebody has made somewhere, or something has made somewhere, that we need to handle and take care of and rework. Okay. Now the 8th waste, I think usually people talk about unused, maybe put you there, unused creativity, or unused people potential. Now, I'd never have liked the labels. Sometimes people even say the eighth waste is people. I would really, if I were you, avoid that one, that language. But what we're really talking about here, and I think it's a good one, although I believe that in order to make it happen, you'll have to communicate it as another waste anyway. What we're really talking about here, I believe, is what we used to call back in the 80s empowerment. So in other words, I want my employees to be able to make decisions on the things that they are more qualified than I am to make decisions. If somebody has an idea for making this particular process better and they're real close to the process, we ought to be willing to listen to them and try it out, and to use their talents as SMEs, and to empower them to be able to say, yeah, I think that this might work. If you ever listen to, I should just mention this. If you've ever listened to, this is not an advertisement for this, although I do think it's fantastic, This American Life. It's a podcast. Ira Flato, I think, is the person who does it, or maybe it's Ira Glass, one of those Iras. And there's an episode called Numi. Okay, and it's a podcast. It takes about an hour. Listen to the first half of it. It's fantastic. And it really shows how the contrast with people who, this was about a joint venture between Toyota and General Motors, so it really kind of teaches a lot of the concepts of Toyota production system at a high level. And what many of the American workers found that was amazing was when they went over to Japan, they were actually allowed to stop the production line if they saw problems, and to suggest what could be possible solutions for how they could do things better, how they could do things faster, and so forth. And that's what we're really talking about. So the waste here is a lot of times like, well, why we could be doing things better, we could be eliminating defects, we could be eliminating waiting, and we could be eliminating over processing, right? So if I have to submit something and then you as a manager have to come down and have to make a signature on something, that's going to take us a lot of time to do. All right. So talked a lot through this, but let me give you some examples. On transportation, for example, in an office, it may be too many approvals. May have to go. A document may have to go through too many signatures, and that can cause all sorts of delays as well. What we could think about is transportation. Or the classic example is kind of movement of material goods. In inventory, we can talk about the classic example, which would be excess work in progress or raw materials of unfinished or finished goods. But we could also be talking about excess marketing materials in an office, or excess reporting. I'm sure you all can relate to that. There's reports that we get that we don't read, and so forth. A classic example of motion might be poor employee layout to complete a task. Maybe that's mixing drugs at a pharmacy. I'm going to be careful there. Mixing drugs at a pharmacy, yes. Or the ergonomic design of a call center. But we can also be talking about sort of where do we arrange the printer, the fax, how we set up the cubes. Waiting, again, I think there are plenty of examples, but it could be queuing at a production machine because of too many batches, or it could be waiting for approvals, waiting for an agent response, a queuing at a call center, or at a lab that you're waiting you're queuing up patients in a waiting room at a lab. Overproduction, making products well before the customers want them, can lead to obsolescence or scrap. However, we could also, and a good example in an office would be completing valueless projects. If a project doesn't have any value, but we soldier on anyway, and we create it, I'm sorry, and we create it, and fix it, and finish it. I think we've all kind of been on that one where I remember early in my quality career, I was on one of those projects where we actually did that, and everybody knew it was a waste of time, and at the end we actually got congratulated for the amount of work that we did and how great it was. All that wanted to make us do was leave. So it was an interesting thing. It would have been great if we had a process in our business that allowed us to very transparently come up and say, I think that here's a project that can be killed, and to have that go through that kill process, and yes, have it evaluated in the right way and have that project killed or stopped. Okay, over-processing can be extra handling, expediting. There can be a lot of ways from that in a typical, in a classic example, rework. But it could be in our office processes. It could be double, triple checking, multiple inspections. Could be excessive reporting, duplicating data entry. Oh, I know that goes on in so many different places where there's multiple Excel spreadsheets. And a classic example for defects, non-conforming product, but it could be order entry errors or errors in invoicing. So all of these things kind of go both ways. They're both in Office and the classical example. I don't think many of us have a problem with that. So try it out. Waste walk is a great way to go through a process, take out the clipboard, and just write some things down. And it doesn't really matter if you write something as transportation and then later you change your mind and say, no, you know what, that really is delay waste. That's okay. It doesn't matter. The important thing is to identify it. And these are just different categories that can help you identify wastes in the first place. Okay. I want to take you through one other thing that I have found very helpful, and that's called process analysis. And the picture of it is given right here. But I want to walk through a specific example because you actually have a template. So I'm going to show you what this template looks like. Here's the process analysis template that you guys have. I've given to you. And there's a blank. That's really blank. There's a blank. And there's an example. That's, oh, hold on. Oh, this is kind of interesting. I've got it mixed up. So the label on here, that's my bad. Just so you know, in the template that you've got, example is the blank one. So this is the one that you would start with, and you would fill in your own process name and enter in the various things. But let me take you through the example here on the other sheet. So this is an example of one that's filled out. And I should say that if you're taking some notes, this is an analysis that you would not do first. So this is a very detailed analysis that maybe after you've done a cursory waste walk, and you've done a process map, a simple process map, maybe you want to get some details on where the different wastes are and so forth. And so the example that's here is a customer rep in a call center looks up a number in an Excel file, puts on her headset, dials a number, has a conversation. So very detailed, right? This is the opposite of the high-level stuff that we looked at before. Has a conversation with a prospective customer, prints a document asking for the prospective customer's signature, walks to the printer, waits for a printout, walks back, puts the printer. Okay, you get it. Okay? So each of those things is then detailed in here. And it's labeled, the first thing is, it's labeled and categorized as either a process activity, transportation, inspection, delay, or storage. And yes, you simply double-click on that and color the thing that you want. So for example, the first 5 things are process steps. We will then note how long it takes to do each of these. This looks like it's in seconds. And then we'll label these as value-added, non-value-added, or this last column is what's called business required, non-value-added. And I just put a 1 in whatever one they are. So for example, if I wanted to say that this was value added, which means it's important to the customer, or if we didn't do it, it's necessary to either as a requirement, or it transforms the service in a fundamental way. That might be value added, and you see when I put in the one there as opposed to the other, it changed that graph over here. All right, let me just put it back to what it was. I write down the time and I label it as value added or non-value added and so forth. And this just shows us essentially how much time is value added, how much time is non-value added, gives a nice little picture for that, and helps us understand where in the process where we might make those improvements. So for example, here's a customer conversation. You might say, well, that takes up a lot of time, but it's value added. So maybe we don't want to start there. Maybe we want to start with all of these steps right here, the walking to the printer, the waiting for the printout, the walk to the office, because all of these are either transportation or delay, and they're all non-value added. Okay? So it just gives us a clear picture for how we might want to proceed, and also it gives us a nice communication tool for saying, for communicating to management as well as to people who are in the process. Anyway, this isn't something that I see an awful lot of people doing, and I think that you'll find that it's a neat little tool. All right. So even though I've provided this in the reading material, I would be remiss if I didn't spend a minute to talk a little bit about value added, non-value added, and business required non-value added. Everybody has different definitions. I'm going to give you mine. Essentially, we used to just have value added, non-value added, and value added was simply it transformed the product in a fundamental way, or it was necessary to deliver to the customer, and non-value added was anything else. But then, many people wanted to add another thing that was, for example, business required. So it's required by a regulator. Say it's something that's required from a regulator, but it's not value added. Some people might say a lot of the HIPAA regulations are non-value added. I would want to question that, but a lot of people would say that. So things that were there that you had to satisfy HIPAA for might be like signature on a document from a customer. Any delays that were from that might be a non-value added. And so forth. It might be a business required non-value added. Anyway, some people have actually put in things that are called value enabling instead of business required non-value added. I would shy away from those. I would consider those to be generally non-value added unless they really are transforming something in a fundamental way that you couldn't do without. But the important thing is really what I do like about business required non-value added is that by saying something is required by the business constraints or by current technology or by regulators, it allows you to then, as a black belt or green belt, question that and go back and say, is it really required? Has anything changed? If so, that may be a way that we can really make a difference. Okay, process analysis, great little tool. And it's a nice little picture that goes along with it. And you have that template in your template directory. Okay. Oops. All right, the last one I want to talk to is something called 5S. And this is another tool that is just so generally applicable. You'll want to use it in many cases. And if anybody has seen the show Hoarders, not really a fan of that show, but if you've seen it, a lot of how they clean things up could be, they use some of these 5S concepts in that. Okay, the 5S's are, and basically these come from Japanese words that also were S words, so it's just a rough translation, but we'll explain what each of those are sort, set in order, shine, some people say systematically clean, standardize, and sustain. And let's talk through what they are. and how something might proceed. So sort essentially just says separate out what you need from what you don't. Okay, so if you come into a, you know what, we'll talk through an example very quickly. Set an order. Find a place for everything. So another thing that people might say is a place for everything and everything in its place. Okay, that's what set and order means. Okay, shine literally means clean it. Okay, standardized means not only am I going to do it, but other people are going to clean and put things away in the same way. And then sustain means sustain is really about, honestly, it's about metrics. Metrics and checking. We're not only going to have a standardized way, we're going to check to see whether those standards are met, and we're going to monitor it over time. So it's really about monitoring. Okay, let's go through an example of this. Suppose that you're like me and you have a garage that's not in order, that could use maybe a little 5S'ing. How would you go about that? Well, you'd start by saying, okay, the first thing I want to do is say, there's an order to this, right? So it literally does go in this order. The first thing you'd want to do is to say, let me find all the things I want to keep, all the things I want to get rid of, and put them in 2 separate piles, and then I'm going to get rid of the things I don't want. Now, we all know that usually you put things in 3 piles. You put things in get rid of, maybe keep, and keep. Right? This is maybe, this is throw out, and this is keep. All right. So you might put them into each 3, but eventually you want to essentially get them into keep. I'm going to keep it, or I'm going to not keep it. Okay, I'm going to get rid of it. All right. So I might say, you know, the old bins that have my old sporting goods equipment from 20 years ago, I don't need those anymore. I'm going to donate those to the local a local YMCA or something like that, and I can get rid of them that way. The second thing is, all right, now that I know what I'm going to keep, I want a place to keep I want to keep all the sporting goods here. I want to keep my lawn equipment there. I want to keep my tools in a different place. Okay, so that's the second part. And again, you can apply this to a kitchen. You can apply it to a garage, anywhere. Now the third thing is, now that I've got everything cleaned up, now that I've got everything organized, let me take some time to make sure I can clean that empty space in between. And I literally mean that. I'm going to clean it. And the reason is because now I've got some emotional baggage. Now that I've got it clean, I've got some emotional baggage. When it gets dirty again, I'm feeling it much more. Right? So the more I can keep it clean, the more I can see it getting out of order. And it's also going to be easier to do. All right. So that's the 3S, and a lot of people are really good at that. What a lot of people are not good at is the back end, which is the standardized, which is creating a consistent approach. So that means that not only am I going to put the basketballs where the basketballs belong, but my son is going to do it too, and my daughter's going to do it, and my wife's going to do it, and we all agree that this is the place where the basketballs belong, this is the place where the rakes belong, and so forth. Okay, this part is harder. Standardizing is harder. And finally, sustain. At that point, we want to ensure that the approach is followed. So once I've got a standard approach and everybody agrees to it, maybe we can check once a week or once a month or once a year or whatever is the proper frequency to make sure it keeps happening. So that's 5S. Now, there's a lot to it. If you Google 5S, or if you don't, I'm sorry, if you read it in a book, you'll see lots of other stuff that's on it. Like, you know, here's what 5S looks like in the beginning of an organization. Here's what it looks like after they've done it for 2 years. Here's what it looks like in the end state. You'll see that. You'll see some examples, and you'll see lots of neat little tricks that people can use to make sure that things stay in order. I might want to also add that some people talk about 6S, and the 6S is usually safety. This seems to be a healthcare trend. So I see this in a lot of, like for example, U.S. Oncology did it. I know in talking with John in our one-on-one, John mentioned that you're doing it at Baptist or did it in a previous place. So it doesn't, at least in my mind, it hasn't fit into like this specific order of things. You're probably going to be considering safety all throughout that. But anyway, just in case you see 6S, that's what it is. Let me show you an example, a good example of what we might mean from 6S. And this is like your grandfather's thing, right? Your grandfather had the tools. But here we've got an outline. We've got a board with an outline for the tools, so we can tell at a glance what's missing. We can see, for example, there's something missing here, and these things are set up so that you know what goes in each of the places. Very obvious. Okay, so that's just an example of something that might help to keep the place clean and help you understand what's missing and what's not. Making it visual is kind of a key here. I worked with one company where, now this is getting out of vogue now, but let me see if I can go to, there we go, where they had a bookshelf and they constantly had these binders that were out that they needed. And what they decided upon was a system where, and I intentionally left some space on the end. Maybe they put a bookmark there, but they put tape across it and then cut the tape so that they could tell when one of these books was missing and which book. And if you can imagine, like 26 of these, when one was pulled, they can immediately see like which book was missing, and it was pretty cool. But anyway, you can apply 5S to all sorts of things. Your desktop, a file share. That's what I've mostly seen. Shared drives, you name it. It's a great tool. Okay, and this is kind of what there's some more detail on set and sort and order and shine and all that stuff. Okay, just be aware that 3S is usually what I see done. I see a lot of people kind of cleaning things up, but then it goes back into disuse. Why is that? Because this is the tough stuff. This is really getting the buy-in, the behavioral part of it, and the change management part. Okay, so there are a number of different exercises. There's 3 exercises you'll have in the next assignment. One is about a value stream. Why don't you actually take a stab and do one of these? Another is to waste walk. A process could be your own process in your house or apartment, or to do a process analysis, or if you like, you can do both, which I think would be very helpful. And then one is actually talking about 5S. And having you do it. And there's no substitute for doing it and learning it that way. Okay. So I want to stop at this moment and ask you what questions do you have on what we covered thus far. We covered 3 what I think are very, very important tools. So we covered some nuts and bolts. Nuts and bolts tools. We covered the value stream map, and remember that we just touched the surface on that. We covered the waste walk, which is really you're taking out that clipboard and you're walking on the floor and you're looking at all those 7 or the 8 wastes if you count unused creativity, which remember is really just empowerment. We talked about process, what I call process analysis. Boy, I said that like a Michigander. Process analysis. All right, and finally we talked about 5S. They're very nuts and bolts tools in Lean. Okay, so what questions do you have on this before we move on? Okay. All right, so let's move on into what will probably be the last section that we covered today. I did want to give an example or two of hypothesis testing, and maybe we'll have a minute or two to do that at the end, 10 minutes or so. But I want to talk through, again, I think that in reading the material and in looking at a number of the tools. I don't think this will present you with any problems, and like I said, most of you have already had some lean. For the folks who haven't had a lot of lean, let's talk about it in our one-on-ones and where you might apply it. But what I want to do is I want to just talk through, here are some solutions. One thing that in fact, Tom Pizdek, and I'll write his name down so you get it. Yeah, I wrote it in invisible ink. That's not very helpful. Thomas Pizdek. Now, admittedly, he is a Six Sigma guy. He came from Six Sigma and quality, not from lean. Okay, but what he noted was that the way that he viewed lean was lean, in many ways, is like a canned set of things that you use to act solutions on. Now, I don't totally buy into that, but I think he sort of has a point. A lot of the things that we think of as concepts in lean are actually solutions or almost solutions that we can apply in different places. So I want to talk through some of those solutions. And we'll talk about five of the types. One is one-piece flow. One is something called cellular flow. One is called load balancing. One is called quick changeover, or some people call this SMED. It's got the really manufacturing name of SMED. Single minute exchange of die is what that stands for. I like quick changeover because most people get what that means. Or quick. Well, we'll talk about what it means. And then the last one is pull systems, or Kanban. Talk about Kanban. And this is probably the hardest to get without doing it. So we'll spend maybe a little bit more time on that, talking about some examples. And at this point, I'm really going to do my best to try and ping you guys to see where you've applied this. Okay, so let's first of all talk about one-piece flow. Before we do, what we're really trying to do, if we think about it from the very, very high level, is we're trying to eliminate wastes in process. And in many cases, that means increasing the speed of a process in terms of delivery to customers and removing those delays. Okay? So I've pictorially represented this by big process steps and long, meaning it takes a long time. But also, we'll notice that, for example, step 3 takes a lot longer than step 4, and there's some imbalance here, right? So we're going to be using these techniques, load balancing, one-piece flow, quick changeover, pull or Kanban, and cellular flow, to shrink that process and to regulate it to get it to run more smoothly. That's the name of the game here. All right. Before I do, I want to go into the concept of, and I'll write it down. Just to, you can Google it or Wikipedia it later or whatever you want. But we're going to use concepts of what's called muda. I'm going to write down all of them. Muda sounds almost the same, and Muri. Okay, now what what the heck is that? Well, muda is, if you hear this term, I think the literal translation means trivia. In other words, this is waste, the way that we usually think of it, stuff that we don't need to do that we're doing. Change this back to red. I like the word trivia. I think that works. Trivia or trivial. Okay. Mura means unevenness. And I'm struggling to spell this. Unevenness. And we can think of this as largely as variation of performance. Okay, so sometimes things perform, you get a lot of performance out of something, sometimes you get a little. So that's kind of related to our concept of variation. And finally, the last one, which literal translation is overburden, which again kind of means understanding what we can and can't do, and standardizing. And there is, even and most people, most lean organizations, they focus on Muda. And in fact, when you ask people, they often talk about Muda, but they don't talk about these others. There's a lot of waste and unevenness and variation. And if you only consider this, you'll never get to this. That's one of the reasons why we look at the 7 wastes. There's also a bit of an order to this. You don't want to start with Muri, generally speaking, because if you start with standardizing some things, you can often get into trouble. So there's a bit of a order here. You probably want to look at Muda first, and then Mura, and then Muri. But think about it this way: why wouldn't you start with standardizing? By the way, a lot of companies do that. They look at a process and they say, what we really need is standardizing. Standardizing, not the first thing you want to do. You want to lean it out by taking out the Muda and the Mura first. Why? Well, let me give you an example, and it will probably work for you. Consider a process where you've got consider any sort of process that you can automate. If you don't eliminate the waste that you're already doing, or the variation that you've got in there, let's say you automate it by putting in an IT solution. Think about how wasteful that is, or first of all, think about how expensive that IT solution would be. We've got to take care of all the exceptions. We've got to take care of all the possible errors and so forth. The second thing is, what we end up doing is suppose that we had many, many steps, and we could eliminate some of those steps because they were non-value added. Wouldn't it be better to eliminate those first rather than to institutionalize them in the code? So hopefully I've given you a good impetus for why this comes last. And by the way, it's also the 4th and 5th S, and there's a good reason for that too. You don't standardize first, you standardize near the end of an improvement. Okay, anyway, that's just kind of philosophical. Okay, so let's talk about one-piece flow. I think perhaps the best way to think about this is, I'm going to jump ahead just a little bit, and then we'll come back to this. Right, so I'm just going to jump to this. There's 2 examples that I hold out as sort of paragons of this. And by the way, these are just potential solutions. We don't want to be a one-size-fits-all maniac. One-piece flow is not always the solution, and you don't always have to get to a piece flow of a batch size of 1. Okay, but 2 companies that used this heavily and were very successful. One was Dell. So Dell Computers became extremely successful company in Austin, Texas. I guess in Red Rock, north of Austin. Very successful company, largely by letting the customer pull. If you remember, Dell in its early days was an internet-based company or a call center where you called and you basically told them the computer that you wanted. The beauty of Dell was that at that time they held no inventories of finished goods. They actually got your payment before they paid their suppliers to ship the stuff and to put it together. So that was their whole methodology, was to let the customer pull, and they were going to build you a batch size of 1, your computer. They're not going to mass produce these things and push them into retail. Now you can see that Dell has had to, in bad times, they've had to readjust their business model. So one-piece flow wasn't the winner-takes-all solution for them. Now you can go to Staples and buy a Dell computer. They make them beforehand, so they have to have some finished goods. So I don't want to give this as the only solution, but it can be very, very helpful. Think about the advantages in inventory. Second thing is, think about McDonald's versus Subway. I have to be careful here. I used to work at McDonald's, and in the old days, I don't know if they still do it in the days of microwaving all your food. Haven't been to a McDonald's in ages. But in the old days, when lunch would come, we had the mentality of, if we build it, they will come. So we'd put in huge batches of hamburgers, Big Macs, chicken sandwiches, fish, all that stuff. We'd put them in the bins so that when people came in and ordered a fish sandwich, we could just pull it from the bin. Well, what happens is, if people don't buy fish or they don't buy Big Macs, after the lunch rush is over, guess what happens to all that inventory? Well, in theory, you're supposed to throw it all out. We always did. I always threw it out, but truth be told, I've seen some people change timing numbers and keep it in there, but whatever. The point is it becomes waste or a customer hazard in any event. But Subway doesn't do that. Subway, when you come in, you order, if you want to order a veggie delight, they only ask you the questions on what they need. They only pull the bread that you want, so they don't have to make a new batch of bread as often. They don't have to throw out bread. So there's lots of advantages. But there's also an advantage in time. And the key thing is one-piece flow only works if you can do it well. If you're not making a lot of errors and you're executing it fairly quickly, one-piece flow works. If you can't do that, it doesn't work very well. Here's an example pictorially of why it can be, of how it can be wasteful. Imagine the top process is one that uses batches. In this case, it looks like it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a batch of 10. So imagine this, that you've got a three-step process. You put 10 things into step 1. When they're completed, you move them to step 2. When they're completed, you move to step 3. All right? What happens is, as you're completing, that first one that's complete has to wait for all the other ones to complete before you move it to step 2, and so forth. All right, if we look at that, if each one of these steps takes a minute, the total lead time to get any one of these, or the whole batch through, the whole batch of 10 through steps 1, 2, and 3, is 30 minutes underneath that one, underneath that batching process. And it's 21 minutes for the first one, whatever this first unit is. Let's say it's this one, which goes in, and it's the first one here, and it's the first one that gets out. That takes 21 minutes. All right, 10 minutes here, 10 minutes here, 1 minute here, and it's done. Now, if we're not doing that, if we're putting one in, and then as soon as that's done, we're moving it into step 2. As soon as that's done, we're moving into step 3. Here's the advantage that you can do here. You can actually move the lead time from 30 minutes to 12 minutes for the entire order, and 3 minutes for the first piece. So the first piece goes bam, 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 and comes over here in 3 minutes, as opposed to waiting for all these others. So that's the advantage. This is all the good side to one-piece flow. As I said, there can be some, it's not a one-size-fits-all solution, so many processes don't lend themselves to one-piece flow very easily, nor do they lead to a production line type of development. Okay, I'm going to move on to cellular flow. So cellular flow is a different sort of concept, but it goes with one-piece flow very well. And that's why I started with one-piece flow. Cellular flow allows for designing something that tries to minimize. One of the things that one-piece flow can do is it can deal with speed and inventory. So delays and inventory, right? Those are the wastes that are really big on this one. Delays and inventory. All right. For this one, this can help us a lot with defects, I'll show you how, and transportation. And some others in motion as well, but those are the first ones that really come to mind. But it also works well with a one-piece flow mentality too. All right, so imagine this. What cellular flow is essentially having a team in an area such that where something comes in is also very similar to where it comes out, and as it goes around, it's done with physically close in physically close stations. UTC used this heavily in their jet engines, and they were able to get the amount of travel of their jet engines in their factories at Pratt & Whitney in Hartford down from like 5 miles of travel on the plant down to like 1.5 miles of travel on the whole thing. And they may have even beat that by quite a bit, but those were the numbers that I had 5 years ago. So a tremendous increase or decrease in the amount of transportation that was done. But there are other advantages as well. This happens to be what's called a U-shaped cell. A U, you end up at the same place that you started. And there are different types. There's a Z-shaped cell as well, but we'll deal with the U-shaped cell. let's imagine your kitchen, and the kitchen is a station that your kitchen is very likely to be designed in this way. You might have a garage, and your kitchen may be off the garage or close to it, and you'll bring in the food, and what's close to the food? Well, the refrigerator, right? And when you want to cook something, you've also got some stuff that you're going to pull from the shelves and the refrigerator. You pull it right there. You can work on it on the counter, and then you have some counter scraps which you put into the sink. Move those right into the stove or the oven, and then we can put it on the service area and can go right to the living room or dining room or wherever it goes. And oh, by the way, the garbage that's created can go right back out of the kitchen as well. So it sort of minimizes all that travel. So that's one of the things. Another advantage that you get is that because if this is not just you working on this, so you can imagine, if you can imagine this as a restaurant, well, you've got the people who are working on different areas communicating with each other. So you can actually keep from passing on errors instead of you do what's called controlling errors at the source. So if this is a different person, let's say this is person 1 and this is person 2, I'll just say P2, that if this person gives the P2 a bad carrot, and they're supposed to be say preparing the carrots, they'll let that person know right away. And so we can start to get bad carrots out of the refrigerator right away. We don't have to wait till it's passed on to a customer for somebody saying, oh my God, I got a rotten carrot. Or worse yet, that's the worst case. But also bad would be, hey, we made the dish and it's got rotten carrots in it, and we noticed it, and we don't serve it, but it's still a problem because we throw it out now, and now it's waste. Okay, so cellular flow can help you with both of those ideas. All right, I want to stop and I want to ask before I go on. I want to ask the folks who are on the phone. I see most people are muted, but if you could take 15 seconds to write down where you have applied either one-piece flow or cellular flow, and maybe take a minute to share that experience. So I'll give you 30 seconds to write it down. Okay. Is there anybody on the phone who could share where they've applied either one-piece flow or cellular flow before? Okay. No answers. That's okay. If we can, that's okay if you haven't yet done it. But as you're going through and applying these things, I believe that you'll find that there's many, many places where this can be applied, and we will work on that in a little bit. Okay.
Yeah, Mark, one thing that we look at in healthcare is since so much of what we do is patient-centric,
yep,
a lot of our larger processes are naturally one-piece flow.
Okay, excellent, right. Now, yeah, and I should
processes like labs and things like that, well then, yeah, you'll encounter some batching, but we're kind of an anomaly like that.
Yeah. Well, the interesting thing is, I think, and I did a lot of work with Cigna, and so this will probably apply at CCI as well, that there were a lot of things that were naturally one-piece flow there as well. But that's an excellent point. Is that in this case, if you're really dealing with one patient at a time, and it's a significantly different path, then it kind of forces you into one-piece flow. You can't batch up patients, at least not that easily. Good point. But I can imagine things like paperwork, billing, mixing drugs or medication, interfacing with the pharmacy, that those could easily be batched up And you know, a lot of time batching processes are things that come about because we're trying to minimize the wrong thing. What I mean by that is, and hopefully this discussion is, some of this is helpful, if we do have a siloed mentality and we're thinking in terms of this rather than this, well, if I'm going back and forth from the pharmacy and that's my process, what do I try and minimize? I try and minimize my time, not the customer time or not the end-to-end time of the transaction. And so I might batch up. I might make it more efficient for me or for my time rather than for the overall. That can happen quite a bit. All right.
That's a good point. One thing we teach our lean practitioners is that batching is a flag. So you can't just go in and say, do things one at a time. You have to figure out why they're batching and dig down.
Right. And that was kind of like, you know, that was kind of what I was getting. I'm glad that you pointed that out. And I think that's maybe that's another good way of looking at it. That was kind of why I was saying that don't think that these are just solutions that are always going to work. You have to understand sort of why it's done. When I learned a lot of stuff, I learned like with mail, through mail order, batching in terms of economic order quantity. And the idea was, well, you want to do some batching in your mailing because otherwise, if you're doing one piece at a time, you're going to spend a lot more money. And while that's true, you find that, man, the delays, and it causes so many delays that sometimes it is better to incur the cost of the extra cost of the shipping or whatever. And it's worth asking is the point. And I think that's what you're talking about. It's time to drill. I like that. It's a flag to look for more. Okay, there are a couple more that I wanted to cover. One is load balancing. I'm sure that many of you basically get it already, but this is a very strong and commonly used lean solution. Imagine a process that has that works at very irregular pace or is overstaffed in some place and understaffed in another. We often have suggestions of solutions like cross-training or switching around people for capacity. Those are good ideas sometimes. And so how can you tell? Well, if you're going to be doing load balancing, we'll start with takt time, which is really sort of how much, what's the demand rate for this product or service. It just means like how many minutes or how many hours do we usually have in order to complete this. And then we'll break that up into what the steps usually take. This is actually a tool that I've given as a template, so you should feel free to use it. And it's called load balancing. Here it is, and basically, I'm not going to. I'll show you how this works, but basically, you take your overall demand rate. This would be, if this is in seconds, for example, this would mean that every 90 seconds, on average, we need to produce something. That may be a customer call. It may be something else. So let's look at the average time it takes us to produce something in step 1. Let's suppose that this had 5 steps. In step 2, in step 3, in step 4, in step 5. So the first thing is it gives you a picture of how long things are taking in each step. So it can tell you, okay, yeah, if we're going to regulate this, we may want to put more capacity on step 3, or we may want to cross-train people in step 4 and step 3, such that when the people who are working in step 4 are done with their job, they can move over. So you can imagine this conceptually as you go into McDonald's and the drive-through gets backed up, so they take somebody from the inside counter who has been cross-trained on drive-through, and they put them on the drive-through. Okay? You can imagine that. Now, in this particular tool, it also looks at what's called the balance sum, and if the balance sum is greater than the process steps, it means that you cannot fix the problem only by load balancing. If you think about it, the perfect solution, perfect balance would be if each one of these took 90 seconds to do, and we were doing one-piece flow, then in theory we could complete one thing when we were starting another, and it would work out that way. So this just kind of gives you a tool to say whether you can solve the whole problem or part of the problem by load balancing. The picture shows you how unbalanced it is, and this kind of gives you an idea in the perfect scenario if you're meeting all of the if you would be able to meet the customer needs. So that's what that is. All right. So that's load balancing. Again, I'm sure that most of you are familiar with some people call it job sharing, and so forth. All right. Let's talk about two more. One is quick changeover. I know that one of you is using this a lot. But here, this is one that is very, very common in terms of being very effective. As I said, it's sometimes called SMED, or single minute exchange of die. In manufacturing, what this means is we don't want to move from doing one task to another by taking a lot of times in delays. So it may be we're going to start a new production batch, like if we're running one type of prosthetic limb and then we're using a different type of prosthetic limb, manufacturing it. We don't want to have to take a long time tooling that up. Or if it's we're moving between, say, shifts at a behavioral health call center where you're taking people who are on a suicide hotline. You don't want to leave people hanging on the line too much because we're changing nurses or something like that, or psychiatrists who are talking on the phone. So anyway, some examples of fixing this would be like hydraulic lifts and readily available tools. There's a company called Synthes that did an amazing job of that, where they had tools on a hydraulic lift that went below the plant floor. And when they needed to retool, they just would bring up the new tools right from underneath, and they'd be ready to go in seconds. To other things where, like, staggered shifts can be helpful. Instead of leaving people hanging, maybe you have a 15-minute overlap of shifts for people to get prepared to go on, and so forth. In non-manufacturing, you can think about things like pre-screening questions so that people come on, they're ready to go. The person who shows up, if they have an appointment, if the appointment really starts at 10 o'clock, they're there at 9:45 filling out their history or whatever. Or there are standard templates or scripts. One thing I can tell you that I dislike at a lot of medical practices is they make the appointment at 10. They say, oh, can you be here at 10? And then when they pre-call you and say, don't forget to come for your appointment at 10, and oh, by the way, can you come 15 minutes early? That one doesn't work for me. Why don't you have me come at 10 and really start the thing? If you need me to do some pre-screening questions, plan for me to do the 5 minutes of pre-screening questions at 10, or tell me to come in at 9:45 at the original appointment. All right. What can often happen in many offices is lack of ownership and lack of standards is really causing delays in the changeovers. So confusion over who owns what often is a major problem in quick changeover. However, having said this, and like I said, at least one of you I know is actively doing this, and so I know that you really buy into this. Here are some things. This can yield very, very big dividends if you do this, and if you take this mentality of it's the delays between the process steps that you can really beat down and really make a big difference in. If you do it, it's really absolutely vital to involve the people who perform the work and to really understand what they need to do each task and what they need to prepare each task to get it ready. Keep a clear scope of what's really being improved. Otherwise, you don't get the buy. You're asking people to do a lot of things that they may or may not believe really will make a difference. And check. When you enact a solution, make sure it actually works. Don't just do it out of logic. Make sure do it and then test to make sure it actually works to help eliminate those delays. So, quick changeover can really be an excellent idea. I have in here videotaping is also very helpful. Sometimes we don't really see what we delay on. So it's a simple and strong idea. I understand there are many different legal obstacles to that sometimes, but if you can do it, it can be very, very helpful. All right. I do want to talk very, very, very briefly about Kanban, and at this point I'll just talk about what it is, and then maybe we can have I'll have you read it, and you can maybe see it in action. When I first learned Kanban, basically what it is it's a process. It's a system that helps you visually regulate things. You can regulate inventory. You can regulate how often things are done, and so forth. All right. So that's all it really is. When I did it, it was a cart. In many cases, it's a pull system with cards, and I believe the Japanese word literally means card. But think about it this way. I believe it started in the mini marts where people visually stacked their inventory such that when it was out, they knew it was time to reorder. So examples for this can be literally visual cues like signs at the bottom of, say, a printer paper that says time to reorder, things like that. All right. Without going into it too much, I see that we're hitting the top of the hour. I do want to take a little bit of time to recalibrate and talk about what we're going to cover on Thursday, and to remind you about the assignments that are due and things. There is an exercise that's going to happen in the next assignment that you'll need to work through, and so forth. Okay, but I believe that none of this, except maybe Kanban, will present you with any problems. What I have on my list is to provide you with a little more reading material so that you can ferret that out and ferret out some of the tools, quick changeover and Kanban and some of those other lean solutions, and to get you that assignment. All right. So when we reconvene on Friday at 11 o'clock Eastern, 10 o'clock Central, we'll talk a little bit about the team tools, and then I guarantee you, we will cover the basics of hypothesis testing so you're not left in the lurch for the next assignment or for the weeks that are coming. The weeks that come are going to require a little more heavy lifting on the statistics. All right. So that's it. Just very quickly, if you have, I understand that I'm over the top of the hour. And by the way, if we can all be on time next time, I think that it's going to be a lot easier to actually finish on time. However, having said that, we covered sort of the lean intro, covered the section on lean intro. Okay, I talked a very brief amount about lean metrics, and we talked about the principles of lean. We talked about nuts and bolts, value stream map, VSM, waste walk, process analysis, and 5S. Okay, looks like SS, which is not good, but 5S. There we go. And then finally, some lean solutions. One-piece flow, red flag. I love that. One-piece flow, cellular flow, quick changeover, and Kanban. All right. So, and load balancing. So that's that. All right. So one last plea. If you haven't yet turned in any of either the first or the second assignment, please turn in that as soon as possible. If you have not yet scheduled your meeting with your assigned partner for the last part of the next assignment, please get that scheduled today. And if you haven't yet started assignment number 3, get moving on it because there's a lot, and it's really a key thing. Okay, I'm going to stay on the line, so I am available for questions. I'm going to stay on the line if you need to. But that's it. Have a great and productive week, and we'll see you on Friday. I'll see you in the one-on-ones prior to that. Okay. Take care.
Thank you, Mark.